Hey, what is going on? It is Monday, March 28th, 2022, and I have another coding problem that I'm going to be throwing at you. It's been a while since we did a tree problem. I did a linked list problem yesterday, and the linked list problem, yeah, that was fun, but let's get a little more complicated and start doing trees. Trees are always a fun favorite of interviewers, and they're just a good thing to know how to traverse. So I picked a random tree problem, and I got this 13, 15 sum of nodes with even valued grandparent. It's listed as a medium problem. Um, and it looks interesting to me because I've dealt with parent tree problems, but this is the first time I've dealt with a grandparent tree-based problem. So this one, okay, so it shouldn't be too bad. So let's see, how do we go around? How about solving this? So let's look at this problem statement first. Given the root of a binary tree, return the sum of values of nodes with an even valued grandparent. If there are no nodes with an even valued grandparent, return 0. A grandparent of a node is the parent of its parent if it exists. Okay, so in this case, the grandparents here in the first example are 6 and 8. Why? Because 6 has grandchildren, which is indicated as the third level. 8, which is on the second level, has grandchildren, which has a fifth, which has only one node, one grandchild, uh, and it is even valued. 7 is also a grandparent, but none of 7's grandchildren. The 7, you won't sum its grandchildren because 7 is an even value. 8, you will sum the grandchildren, which is in this case only 5 because it is even valued. 6, you'll sum all the grandchildren together because they are because 6 is even valued, and that's how you basically tackle this problem. You've got to have awareness on each iteration or call stack or however you want to traverse this tree. You have to have awareness of who the value of the grandparent and also whether there are grandchildren. Okay, so first of all, let's think about how do we determine if there is a grandparent. First, what I'm gonna do. There is this. I think this is gonna be a DFS problem, right? So what we're gonna do, I'm gonna create a helper function called DFS. Okay, I call my helper functions DFS, but if you're in some kind of interview situation, then you should probably refer to them as uh, what it is. So this is, you can call this grandparent traversal or something like that. So I like to, these problems, there's a little bit of a kernel that I'd like to put into place. We're accumulating something. So instead of returning a return value as the thing we're accumulating, I'm passing it in. In Java, you can do this and at very little cost, and you can have an object reference to an array to store the value of what you're trying to pass by reference through the entire array. And this is a nice, neat little trick because you don't have to, if you're not sure what the return value is or should be, but you kind of know how to traverse the array and you know how to accumulate a value, this is a good way of passing that value in without putting too much extra thought into what the return value should be of your helper function, because you are actually, it's essentially another way of returning a value. So I'm going to call this sum, right? And you'll see the main kernel function returns the value, the 0th index of the value of sum. If you don't understand this, this is fine. This is just think about it a bit and it'll make sense. So what this is saying is I'm creating a new int array with one value at 0. Okay, I'm initializing it to 0 because the problem asks return 0, and it's asking me to return an int, not an int array, but that's fine. If I return just the 0th element of the int array, then I'll be returning the value that I'm seeking. So that's just something to get some practice with if you're not familiar. This is just another way of treating return values in helper functions. So now what I want to do, I want to determine whether the grandchildren have an even value grandparent. So the grandparent, right, is going to be the root at some point. Okay, if root dot val equals 0, 2 equals 0. So this is how you tell if something is even, if if modulo 2 is 0. Okay, so now how do we determine whether this is a grandparent or not? Okay, so this is just, think about this. So if root dot left is not equal to null, right? Total plus equals root dot left val. Okay, so that's how I know this is a grandparent, right? Because firstly, okay, and one other thing we need to keep in mind. This is where it gets a little bit nested, but you can follow the logic. If root dot left not equal null. Okay, so a grandchild is going to be in a situation where it has the grandparent has a child and the grandchild. So if the grandchild exists, remember there can be 4 grandchildren, right, per parent at most for grandparent. So the first grandchild is going to be root dot left, and if it's not equal to null, and you have to first check if root dot left is not equal to null. If you don't check this, then you'll get a null pointer exception. So you can't just check the parent right away, the grandchild right away. You have to check the child as well for nullity. So this is how you get so how would I get the second grandchild, right? It's not too bad. If root dot left dot right is not equal to null, remember, because this is root dot left, this is root dot left right, is not equal to null, then I'm going to sum the value of root dot left dot right dot val. Okay, so cool. Now that's cool, but am I done yet? The answer is no, because that's getting only 2 of the grandchildren if they exist. How do I get the other grandchildren? How do I get 1 and 3? Okay, not too bad. If root dot right is not equal to null, because root dot right is going to be the child that has the remaining grandchildren. If root dot, and again, this is a lot of dots, but you can get the idea. Root dot right dot left is not equal to null, then total 0 plus equals root dot right dot left dot val. Okay, so again, that's the next grandchild, right? And that makes sense, doesn't it? Because at this point we have 3 of the grandchildren, and that's going to be the next, if it exists. We're checking for these conditions of whether it exists right off the bat. And what's the last one? Finally, root dot right is not equal to null. Okay. Total 0 plus equals root dot right dot val. Okay, cool. All right, and then that's getting the sum of the grandchildren. And now what do we do? Okay, now that we have the sum of the grandchildren, we have to actually do the traversal. The traversal is, I think, it's your standard DFS. We're only looking at the root, right? And we just pass in the total because we need the total value to accumulate the value across recursions, right? And we're only doing that, remember, this total we're only doing this because I'm not returning the value and here. And this is more intuitively simple, I think, because this allows us to keep track of the values we need to keep track of without having to wonder, oh, okay, what if I return this value here? What if I return the root here and then, this ends early? No, you don't have to worry about that. I can just focus on the DFS and accumulate along the way. Okay, so let's see if this works. Okay, solution cannot be applied to given types. Run line 19. Added an extra null here. Okay, in the kernel function. and accepted. Great, great. Okay, and now let's submit the whole thing. Um, okay, pretty good, 78%. I could have probably done some kind of stack-based solution, iterative DFS, and probably made it faster and that would save some more memory. But I mean, to me, this was a more intuitive solution. So yeah, we did it. Okay, so if you like this problem, like, subscribe, and comment. It helps the algorithm. It helps me, and I appreciate all the support. And let me know what you think. If you have any comments, I'd love to hear them, how I can improve, etc. And with that, happy coding. I will see you around next time.